Beginning, let's begin by starting. Listen.
That's a good idea.
Okay, so today we're going to talk about a sort of just smattering of population issues and questions around ethics with regards to population. So we're just going to talk about lots of different things in that area, and then we've just got some questions to reflect on each of those things. So the first thing I've got is IVF. So that's in vitro fertilization, and that is where we basically take some sperm from a father and some eggs from a mother, put them together, and we fertilize the egg in a test tube, and then we put that inside the womb of the mother, attach that to the womb, to the wall of the womb, in order to aid in conception. Okay, so the purpose of it is it's sort of a way to help people who can't have children to have children. So it's a way that science can help in that way. So, I mean, there's a little bit of the process involved, and it's been around for a fair while now, sort of 20 to 30 years, I think. So maybe even some of you guys are babies that were conceived by IVF. So, one argument against it, and this would continue on with what we were talking about yesterday, but I do not want to dwell too much on that, is this one here. In IVF, many zygotes are frozen or destroyed. Okay, so they're refining the methods at the moment, but I think generally with each IVF process there's about 8 zygotes that are formed, and they take one of them, and they often discard the rest, or keep them if the person wants to use them at a later date. The argument one of the arguments we made yesterday is that a zygote is a unique human being, and so therefore in IVF, you have many unique human beings just sort of thrown away or frozen indefinitely. All right, so one to think about there. Another issue is with regards to what's happening with the human race at the moment. So this one is a bit inflammatory. First, I'm just going to describe, natural selection. I think we've probably got a reasonably good understanding of that, but I'm just going to describe it very briefly so that we can understand how it works, make sure we're all on the same page. Okay, so let's say there's a family of mice, and the mum and dad, they have three mouse children, all right? And here I've drawn them in order of fastest to slowest. Okay, this one is the fastest at running, this one's the second fastest, and this one is the slowest. Okay, so then a slithery snake comes along, and it's going to eat. All right, it's got to eat. So which mouse is it going to eat? Okay, probably the slowest one. It's much easier to catch, and so it's going to eat this one, which means these are the 2 that survive, and they're going to be the ones that breed and pass on their genes, and so that their babies are, generally speaking, reflective of their genetic quality. So their babies are generally going to be faster. And then it happens again. Okay, so these mice have babies, and let's say they have 3 babies again, and the slowest gets eaten. So there's a pressure on the species for the fastest mice to survive. Okay, that's how natural selection works. That's what we mean by survival of the fittest. And when we say fittest, we just mean most fit for survival, whether that be fastest or strongest, or with the sharpest teeth, whatever survival qualities that can help you to survive. Okay. So when we talk about child mortality rate and the average age of death, you might look at some history books and you'll see the average age of death in the past is like 40, all right? And so what you would suppose by that is people didn't live very long, that they would sort of live up until they're 40 and then they would die. But that's actually not quite the right way of reading it. The reason it's so low is because heaps of people died during their youth, during childhood, okay? And so most people would still live to 60, 70, 80, but because you have heaps of people dying when they're young, it brings that average down. So a better way to think about it is with what we call child mortality rate. And so that's the rate at which people will reach the age of procreation. Generally, we say the age of 21, okay? So they've reached adulthood. So just roughly speaking, 500 years ago, every person that's born has a 50% chance of reaching the age of 21. Okay, so straight away, half the people in this room would be dead because of viruses and lack of hygiene and so forth. Okay. Now, so that's 500 years ago, 50% of people. All right, so it was only the fittest 50% that survived. Now in the Western world, in Australia, 99.6% of people reach the age of 21 of procreation. All right, so the question is, what does that mean for our gene pool? Well, it means now we're no longer the fittest and healthiest that are surviving, but it's just everyone. Even those with the sort of poor genes that would normally have been removed from the gene pool. The last thing I've written here is just an interesting side note. When you look at how many male to female ancestors you have, you'd think you'd have the same amount of male ancestors and the same amount of female ancestors. Okay, it's not strictly true. You have twice as many female ancestors as you do male ancestors. And so what that means on average is that you have sort of one man who would have children with 2 or more women. Okay? In fact, if you go back between the year 8000 and 4000 BC, you have 17 female ancestors to 1 male ancestor. So you sort of had these, I suppose you could say, alpha males that were doing all the mating and lots of males that weren't. All right, and that all of our genes derive from that. Okay, so we talked a little bit about natural selection. We also have what's known as artificial selection. And that's where we're selecting a trait that we desire. So artificial selection occurs in fruits, in foods. We see it in animals that we eat. So here we have a peach from 4000 BC. It's from China. That's where they originate from. That's where they first started out. And you can see they're sort of small. They're very small, and they've got quite a large pip. 36% of it is the stone. And then let's compare it to the modern peach today. Okay, it's an artificial peach. We've done that by growing the trees that have more flesh on them. Okay, so some peaches have more flesh. We say let's plant those seeds, and we do that after generation after generation after generation. Eventually, we're making a peach that has 10% stone, and it's mostly flesh, and it's mostly sweet and succulent and delicious. Okay, so we have artificial selection occurring in fruits. We have it occurring in chickens. All right. So this is these are broiler chickens. That's what you eat from KFC, and anytime you buy chicken from the supermarket, they're all broiler chickens. And you can see here the differences in weight. I need to caveat that it's at 6 weeks, okay? 6 weeks old. That's when we harvest chickens from birth to harvest time. And so that, plus artificial selection, plus growth hormones, okay, gives you those nice plump chicken breasts that you get from the supermarket. Okay, so we've talked about, one potential problem we have with humanity, okay, is we have lots of people who are alive that, in terms of natural selection, shouldn't be. And they're contributing to the species. They're spreading their genes throughout the species. So one way it's been described is that they're polluting the gene pool, all right, by having all these sort of bad genes present in humanity's gene pool. Ones that aren't really good for survival, okay? We're no longer just letting the fit survive, it's anyone who's anyone's fit survive. All right? So, the eugenics solution. We could, as we've seen with peaches and as we've seen with chickens, we could do the same for humanity. We could create this superhuman race. We could select for the people who are the most intelligent, the most athletic, the most amiable. That sort of means friendly and virtuous and kind. We could select across all these sorts of domains for the ultimate human being, okay? And so it could be you made everyone infertile, Okay, everyone's infertile by default. And then if people want to have a baby, then you would give them a zygote that is the genetic code of these most elite human beings that we've selected for. Okay, and so that they're not raising their own children as such, but they're raising these elite human beings. And so then the eugenics solution says, now think of what it would be like after 2, 3, 4, 5, 6 generations of doing that. Okay, of just selecting the absolute best from the absolute best from the absolute best. What we could do for humanity. Utilitarianism, deontology, virtue ethics, they all say something different about it. Okay, so we're going to step away from that one now, because that's a fairly sort of inflammatory position. Let's talk about population growth. Skip the slide there. Okay, so when you look at the population of human beings against time, all right, this is what we see. So we have the plague there, wiping out about 1/3 of the world's population. But we see a pretty constant sort of trend until roughly the sort of industrial revolution, modern medicine, when we start to get hygienic and when we start immunizing. Okay, and so we're no longer subject to natural selection. We're just, everyone's surviving, everyone's breeding, and the population of human beings just booms. So some people have described, and you saw this in the Matrix, you have Agent Smith describes human beings as a virus on the planet. Humans just kill everything, everywhere they go, they destroy everything, they ruin everything. And it's a fairly pessimistic outlook. When you look at the out of Africa theory for the genesis of humanity, it says, you know, everyone is related, every human being, and that human beings came out of Africa. Well, modern human beings sort of existed in Africa 200,000 years ago, and we sort of started to wander out of there after 100,000 years. So you can see the journey through Europe, everywhere that's green, that's sort of happening 100,000 years ago. And then you have them coming over to Australia about 50,000 years ago. And during this time, sea levels were lower. Okay, so if the sea level's down, it means more land is exposed. And basically, Australia was connected to Papua New Guinea. It was connected. That was the same piece of land. Australia, Papua New Guinea, Tasmania, all connected, because if the sea level's down, then that land mass is exposed and you can walk over it. But they would have had to have taken boats from around these sort of Indonesian islands and so forth. Okay, so boats were being taken. But they come to Australia about 50,000 years ago, 60,000 years ago, maybe further. Okay, but we have the sort of the Indigenous people arriving in Australia, all right, the advent of the Indigenous people arriving in Australia, and we're told Indigenous people living in peace and harmony with the land, okay? Not really the case, all right, because as soon as people arrive in Australia, you have mass extinction of all the megafauna, all right? So if you drive through Naracoorte, okay, actually from Naracoorte, do you know the name of the big wombat? It's called a diprotodon, all right? So human beings arrived somewhere between 60 to 50,000 years ago. Diprotodon extinct by 50,000 years ago, okay? Big, massive animal, lots of meat, very vulnerable to human beings, okay? And just completely extinct. We see the exact same thing happening in America, all right? So human beings couldn't get to America until around 10,000 BC. And the reason being, there was water in the way, and they didn't know how to get across there. All right. Well, it's a significant break that they didn't cross it. But then we have Ice Age. So we have an ice bridge that connects Russia with the US, and so people walk across about 10,000 years ago, and you see the exact same thing: extinction of all the megafauna, all the way down through both North America and South America. Okay, so we have the advent of humanity, extinction of megafauna. When I say megafauna, that means big animals. They take a long time to grow because they're so big, very vulnerable to human beings. Woolly mammoths, okay, saber-toothed tigers, those sorts of things. What else do I need to say about that? Oh, the other thing is, like often the way these people would hunt, okay, so both the Indigenous people here and the Indigenous people in America, is they would basically just burn forests to the ground, okay, burn the forest so that the animals will rush out into the field, so you can catch them in the field easy. If you think of a forest that's sort of dense, there's plants everywhere, it's difficult to navigate, easy for an animal to escape or run away or hide. If you just light the forest on fire, the animals run out, lots of food for everybody, big party. Okay. So we can look at that and sort of condemn that, but we can also look at that and see, well, what were they doing? They're just trying to survive. So we can think of overpopulation an issue, heaps of people on the planet. We think of things like climate change, natural resources. Is there enough food? Is there enough space? What are some possible solutions to overpopulation? Okay, the first one would be you could limit how many people children can have.
How many people children can have?
How many children people can have? Did I say it the other way?
Yeah.
We can limit how many children people can have. You could put a tax on children. So at the moment, the government incentivizes you having children. You get paid for having children. We could make it the other way, that you have to pay the government in order to have children. We could euthanize the elderly. So this is an argument that's been made as a way of combating euthanasia, and we will talk about it when we get to euthanasia next week, is that, you know, they're sort of 60, 65, they've had a pretty good run, they've had a good life, time to make some room for someone else, you know, someone else who should have the opportunity to lead a good life. Thanos finger put that in there as a joke. Okay, so these are some sort of issues. Perhaps overpopulation is an issue. Here's some potential solutions. But then we should ask as well, is overpopulation an issue? What would it mean to say it's an issue? Why is it an issue? So let's break it down and look through these sort of different analyses. The first is, there's not enough food. People are starving. Okay? So in the 1970s, 4 billion people living on the planet. Now in 2020, we've got 8 billion people, so we've doubled the world's population. Okay? In the 1970s, 50% of people living below the poverty line. So what's that at the moment? $2 a day or $1 a day to eat. In the 1970s, the equivalent of living below the poverty line. Now, in 2020, it's just under 10% of people living below the poverty line. So despite the world's population doubling, more people are being pulled out of poverty every day. So the statistic is about 160,000 people are lifted above that poverty line every day. All right, that their lives are declared such so that they're no longer declared in poverty. So in terms of food, okay, it says if people were to, you could grow enough food for everyone on the planet in a space the size of Texas. So Texas is one of America's largest states, okay, but saying you could grow enough food for everyone on the planet in that space. What else do I need to say about food? Oh, the other thing is we waste heaps of food. Yeah, like almost over a third. I've heard between a third and half of our food just gets thrown out because the carrot's not straight and the apple has a little bump on it. All right, it's got these slight imperfections, we just chuck it out. So food's not really an issue, nor is space. Like, look at Australia, a massive landmass. Most of it is completely unpopulated. Most people tend to live on the coasts or in big cities. There's plenty of space. It's not like we're running out of space for people. We have economic problems. I might talk about decay in a moment, so rather than talking about it now. The last one though is natural resources. Okay, so when we think about things like coal, okay, yes, a limited amount of coal. All right, and so as we're using it, there becomes less and less, but also we're putting carbon in the atmosphere, and some can say that that's really driving climate change. All right, so very true, and we see that since the Industrial Revolution. Okay, so 200 years ago, invention of the steam engine, you have lots of carbon being pumped into the atmosphere. That wasn't the case before. So what about this line then? The existence of people doesn't destroy the planet. Rather, it's how people treat the planet that destroys the planet. Okay, so this says you could have a population of 50 billion people if everyone was living in a carbon neutral manner. So it's not people as such, but how people treat the planet. And you look at humanity, we're trying, aren't we? We're putting up windmills and solar panels. Don't know anyone that's actively trying to kill the planet and cause destruction and pollution and chaos. There are also some negative effects of population decay. This graph up here shows the current birth rate, the lowest fertility rates or lowest birth rates in some of the countries. So the birth rate is how many children each woman is having. Okay, so we've got Taiwan, 1.07. Now for a stable population, the birth rate needs to be what? For a stable population, what do we reckon? 2, spot on. Yep, it needs to be 2, okay? Because if a woman's having a child, you'd think she has to have a child for her and her partner, okay? Because the partner can't have the child, so a woman's having a child for her and for her partner. She needs to have 2 children, and generally we round that up to 2.1 because not every child will have their own children, and not every child will for whatever reasons. Okay, so we have sort of these low fertility rates, and this is the case in Australia. Like the birth rate in Australia is like 1.7 or 1.8. Okay, so it's below replacement, but the population of Australia is still growing. Okay, why is that the case?
Have people migrating?
Yes, immigration. We have people coming in, and so it looks like our population is sort of booming and growing, but our average birth rate is on the decline. Now, what are the problems with this? Okay, the first is if our economic system relies on population growth, okay, we're a capitalist society. It's all about investment in the future. Here's a good way to describe it. In Australia at the moment, 25 million people, okay? Let's say the population peaks and starts to go down. We have 25 million people, we have 25 million houses, okay? Let's say 50 years in the future, we got 20 million people, but 25 million houses, infrastructure for 25 million people. What happens to the price of houses? We have more houses than we do people. All of a sudden it's like, well, I don't need a house, I don't need 5 houses. There's no point having extra houses if there's no one to rent it or purchase it from, and its value just depreciates completely. That's the case with all material things. There needs to be a demand for it in order for it to have value, okay? And when we have a declining population, material things lose their value. So there's an economic problem. The other one is, if you have a declining population, what you have is this sort of old bubble moving up through the population. So let's say population peaks now and then starts to decline. You're going to have lots of elderly people, 60, 70, 80-year-olds, and not many young people to support them, okay? In whatever way that might be, through growing food for them, and making sure the power plants are running, and then caring for them, wiping their bums and stuff in old folks' homes. Okay, so some solutions to population decay if this turns out to be an issue. So at the moment, using current world projections, the population is expected to peak in 2060 at just over 10 billion people and then start to decline. That's the predictions we're making at the moment. So, we're sort of confronted from both sides. Overpopulation is a problem, we're destroying the planet. If the population starts to decrease, well, there's economic problems and it puts a strain on this sort of old bubble that's growing up through time. So some solutions. We could have the government just grow children and raise them so that the government's sort of raising citizens. You could force families to have children. And the last point I've got there is about the nuclear family and inequality. So in the Western world, we're really seeing a change in what a family means. That word nuclear family sort of is appealing to a traditional family with a mum, a dad, and some kids. But nowadays we're seeing with the advent of divorce and same-sex couples and so forth, the idea of the nuclear family doesn't exist. It's still mainstream, but it's not completely dominant, okay? And some problems with this is that nuclear families create inequality. And there's a lot of studies that have been done on this, but basically if there's 2 parents and they're actively involved in their child's life, then their children are generally more academically successful, all right? Okay, last one. We've got 2 more. CRISPR gene editing technology. So this is what's happening in biotechnology at the moment. We're taking strands of DNA from different things and smashing them together. Okay, so we've done it with corn and salmon. So with corn, we've made it so we can grow corn in hotter and drier places with less water. All right, you might think, great, wonderful, we can grow more food, easier, cheaper. Same with salmon, we can make them bigger and fatter and more resistant to the cold. Another thing that's potentially on the case with CRISPR is making our lives longer, elongation, making them longer. So what causes death? You know, people aren't heap sure of, but one thing we have noticed is that our telomeres get shorter and shorter and shorter. Okay, so one thing we could do is stop that happening. How could we do that? Well, there's a couple of ways. One might be splicing our DNA with that of a jellyfish that doesn't age. Okay. One thing we see as well though is you wouldn't necessarily just want to live forever. Okay, so my nana, she died a couple of years ago now, but she was in an old folks home, and she's one of those people that just loved it. Okay, which is great because you want to see people that are really enjoying their life. And I always tell the story of I said, "Oh Nana, I was asking her something. I was like, oh, what street did you live on? What school did you go to? Or something like that. You know, something really simple." And she was sort of thinking for a bit, and then she started laughing. And I said, "Oh, what's so funny? What's so funny?" And she said, "I can't remember." And so she was laughing at herself that she couldn't remember, you know, what school she went to when she was a kid. And so you might think, oh, that's terrible that they're sort of losing their memory. But here's an example of someone who was who saw the sort of joy and even humour in that. So we can elongate life, right? And that's probably what we're doing to a large degree in lots of old folks' homes with medicine. We're making their lives longer, but we also notice their quality of life may decrease as well. They're not exactly running around climbing, doing rock climbing and water skiing and sort of fun things that maybe they really enjoyed in their youth. So that raises questions. Would you be happy to sort of live a long time even if you were confined and restricted? Or do we just need to slow the aging process? Or maybe we can even make people immortal. What have we got? We talked about splicing animal and human DNA, so it doesn't necessarily just need to be for longevity, but if you think about the eyes of a hawk, all right, and the fact that they basically have lenses and can see from incredible distances in a great amount of detail, or the ears of a fox that can sort of, they're very attuned to hearing different sounds and they can point them and so forth. So you could merge human beings with these desirable qualities of animals. And you could even do so when I've got transhumanism written there. That's merging human beings with technology. So at the moment, in a way, we're sort of already participating in that. You look at your phone, and you're connected to a digital world. You can make all those kinds of arguments, but you have the world's knowledge base at your fingertips. Okay, and so there's a pathway. What about eliminating that pathway and just making an attachment to your head? Okay, so you can that sort of knowledge. Okay, but also robotic arms. Okay, why not? Jetpack. Okay, so you don't even have to walk, you just sort of levitate everywhere. All right, so all these sort of things are on the horizon in terms of our scientific progress. We can make clones of people. It's funny, this is sort of explored in the film Gattaca. Can I just see a raise of hands who's seen Gattaca? It was on our film, it's excellent. Okay, so I'll just recount very briefly one of the points it's making. It's saying, if we go for down this sort of designer baby track, okay, we're going to live in a world where you have people, superhuman beings, okay, because they've taken the best genes from the mum and the best genes from the dad, the most desirable qualities, and then we're going to have these other people who are just sort of your normal average human beings, products of the natural process. And that's what happens in Gattaca. So the main character and his brother, that's the difference between them, isn't it? His brother is one of these superhuman beings, and he's not. So it'll only be a problem for a little bit. Okay, here is the last issue we're going to talk about: antinatalism. And so you can find a few advocates of this, and they tend to be people that look at humanity as a virus, but they also see humanity and our lives as mostly suffering. Most of the time we're just sort of suffering and in pain and uncomfortable, and we get these short spurts of happiness, but most of the time our life is spent trying to pursue happiness and never really achieving it. So the argument here, it is wrong to bring children into a world of suffering, therefore we should not have children. And so you find these proponents, they're not having children, and they're trying to convince other people to not have children. And so they're saying we should die out by not having children. That's their thesis. Okay, so we've talked about lots of different things there, lots of smatterings of ideas. So we'll pull our books out and run around and have a chat, and that's all the plan for today.